Hello and welcome viewers. Today we are going to discuss about the H parameters of the transistor. H parameters are known as hybrid parameter because they utilize Z parameters, Y parameters, voltage ratio and current ratio to signify the relationship among the current and voltage in a two-port network. These parameters are advantageous in describing the input-output characteristics of circuit while it is not easy to measure Y and Z parameters, such as in a transistor. A transistor can be treated as a two-port network. The terminal activities of any two-port network can be given by the terminal voltages V1 and V2 at parts 1 and 2 correspondingly and current I1 and I2 entering parts 1 and 2 correspondingly. These four variables are V1, V2, I1 and I2, where two can be designated as independent variables and the lasting two can be represented as independent variables. This indications to numerous two-part parameters out of which the succeeding three are more essential. Number 1. Z parameters or impedance parameters. Number 2. Y parameters or admittance parameters. Number 3. H parameters or hybrid parameters. Hybrid parameters. When the input current I1 and output voltage V2 are preceded as independent variables, the input voltage V1 and output current I2 can be specified as V1 is equal to H11 I1 plus H12 V2, where V1 is the input voltage, I1 is the input current, and V2 is the output voltage, I2 is the output current. I2 is equal to H21 I1 plus H22 V2. These expressions can be represented in terms of square matrix. There are four hybrid parameters such as H11, H12, H21 and H22, which are defined as follows. H11. This is defined as the ratio of the input current and input voltage while the output port is short-circuited, named as input impedance and which is represented in ohm. H22. This is defined as the ratio of the output current and output voltage while the input port is open-circuited, named as output admittance and which is represented in MHO or mho. H12 is equal to input voltage by output voltage. Sometimes it is named as reverse voltage gain. It is unity-less quantity. H21 is equal to output current by input current. Sometimes it is named as forward current gain. It is unit-less quantity. As we can see, dimensions are not alike because they are hybrid in nature and these parameters are named as hybrid parameters. Advantage of transistor hybrid model. Number 1. H parameters are real amounts up to radio frequencies. Number 2. They are not so hard to measure and can be determined from the transistor static characteristics curves. Number 3. They are suitable to utilize in circuit analysis and design. Number 4. Simply convertible from one configuration to further. Number 5. Freely provided through manufacturers. The H parameter of the transistor depends upon the type of configuration, that is, common emitter, common collector, and common base. That's why every H parameter contains a second subscript letter where E stands for common emitter, B stands for common base, and C stands for common collector. The basic circuit of the H parameters as shown in the below figure, which is similar to all three configurations except their parameters. Here, the circuit and the equations are usable in the case of either NPN or PNP transistor and also not dependent of biasing method or the type of load. To originate the hybrid model in the case of a transistor, consider the CE circuit shown in the figure. The variables are IB, IC, VB which is VBE and VC which is VCE. IB and VC are considered as independent variables. In that case, H parameters are a system in the case of characterizing bipolar transistor, but only a few parameters are frequently used, which are HFE or hybrid forward emitter and HRE or hybrid reverse emitter. In today's lecture, we have learned the basic description of hybrid parameter, two-port devices and network parameters, significance of transistor H parameter, advantage of transistor H parameter. With that, we are at the end of this lecture. In the next lecture, we will meet again. Till then, practice the relations repeatedly. Thank you and goodbye.